Good morning, student. Next topic is cells in parallel. How will you connect this cells in parallel? In parallel connection, all the positive terminals of the cells are connected to one point and all the negative terminals to a second point. Here, all the positive terminal of the battery which is connected to one point, the other side of all the negative terminal of the battery should be connected in another one point. These 2 points from the positive and the negative terminal of the battery. Let n cells can be connected in parallel between the point A and point B, and a resistance R is connected between the point A and B. This is the R resistance connected between the point A and B. Let psi be the EMF and R the internal resistance of each cell. The equivalent internal resistance of the battery is 1 by R EQ. EQ means equivalent internal resistance. 1 by R EQ is equal to 1 by R plus 1 by R plus up to 1 by R nth term. So now the total amount of equivalent internal resistance can be written as N by R in parallel. So the equivalent resistance, rearrange this equation, is equal to R by small n, and the total resistance in the circuit can be written as capital R, that means external resistance plus small r divided by capital N. The total EMF is the potential difference between the point A and B. The total EMF is nothing but, let me calculate it, between the point A and B, which is equal to psi. This current in the circuit is given by, according to the Ohm's law, the current can be written as I is equal to V by R. Here V is nothing but psi, is divided by total amount of resistance is nothing but small r divided by small n plus capital R. So I is equal to psi divided by R by n plus capital R. The next step is I is equal to n psi divided by R plus nr. From the last step can be written as equation, rearrange this equation, I is equal to n psi divided by R plus small n plus capital R. So case A, if suppose internal resistance capital R, small r greater than capital R. Capital R means external resistance. I is equal to, the equation can be written as n psi divided by small r, because capital R is very small value, should be neglected from the equation. I is equal to n psi divided by small r is equal to n into I1, where I1 is the current due to the single cell and is equal to psi divided by small r. When R is negligible, thus the current through the external resistance due to the whole battery is n times the current due to a single cell. Case B, if suppose internal resistance lesser than capital R, I is equal to psi divided by capital R. The above equation implies that current due to the whole battery is the same as that due to a single cell. Hence it is advantage to connect the cell in parallel when the external resistance is very small comparing to the internal resistance of the cell. This point is very important for the objective type question. It is advantageous to connect the cell in the parallel when the external resistance is very small compared to the internal resistance of the cell. Thank you.